This is the topic forces. Actually, this topic is famous for moment turning effect, which is the main topic here. Resolution of forces, equilibrium of forces. These are the second topics from this chapter. But this chapter is mainly famous for moment of forces. A glider is descending at constant speed at an angle of 15 degrees to the horizontal. Constant speed is a very important thing. The diagram shows the directions of the lift L, air resistance R, and weight W. Which vector triangle could represent the forces acting on the glider? So I hope you remember the case of constant force, and whenever force is constant, it means it's a case of equilibrium. So I remind it here in my notes. Constant speed means resultant force 0, acceleration 0, object is in equilibrium. And when equilibrium is there, there are two methods to solve a question on equilibrium. One method is called resolution of forces, and second method is called triangle rule. I hope you remember there are two methods for dealing with equilibrium.
The head-to-tail rule.
Head-to-tail rule is for resolution for addition of vectors. Head-to-tail rule, I'm talking about triangle rule. If you join the three forces head to tail, as you said, if there are three forces in equilibrium and the object is, if there are three forces acting and the object is in equilibrium, when you join them head to tail, you will get a triangle. So I'm joining them.
So is triangle D like equal to this one?
We have to see which one actually matches with it. Which vector triangle could represent the forces acting on the glider? So what you had suggested, one diagram. I have made this one, but this diagram is not matching with any option. So we can say head to tail triangle rule. All forces should be head to tail. Option A is not matching. B is not matching. C. Actually, all the forces shown in the diagram should be the same. So you're right, D is the only option here because it shows all the possible forces. I have made an option here, and this option is also right, but the option is not in the working. In the options available. So it should be head to tail. Now, in a high wire circuits at a man of mass 85 kg is standing at rest at the midpoint of the wire. The wire on either side of the man is at an angle of 20 degree to the horizontal. What is the tension in the wire? I'm resolving it. So I resolved them, and it's a case of equilibrium.
So T sine 20 will be equal to mg.
You have to add both of them, no?
Okay, there are two T sine 20s.
Hmm.
It is coming as 1.2 to 10 to the power 3 newtons.
1.2 into 10 raised to power 3 Newton. So it means 1.2 kilonewton.
Yes.
So that's good working. And so I hope now you remember what chapter is this. This chapter is famous for two main topics, moment of force and resolution, triangle rule, center of gravity, center of mass. Now we see this one end of a U-shaped tube attached to a gas tap.
Sorry to interrupt. I am doing like a lot of these questions from the yearly, but I'm getting a common problem in like one of the topics,
Which
like
topic?
about the moment of force.
So can you share me some problem? We can put an extended class tomorrow and you can mark the queries. You must have EM number and we can open the question here and we can discuss.
Yes, I can also share the pictures of the few questions.
If it's a small problem, I can send you WhatsApp. And I have also shared with you the queries links. But it would be ideal if a common problem is coming, we should discuss it here. One
Yeah.
end of a U-shaped tube is attached to a gas tap with its other end open to the atmosphere. It contains water of density and the height of both sides of water column are shown. What is the pressure of the gas from the gas tap? So we should take the difference. I have marked pressure as P1 minus P2.
It is 21.2, the delta H.
21.2. I have shown some working.
It is coming as 1.03 into 10 to the power 5.
Sorry, what you are saying?
1.03 to 10 to the power 5.
So that means answer is D. A shelf PQ is attached to a vertical wall at P and supports a book. This looks to be a moment question. The shelf is held horizontal by a rigid bar as shown. The weight of the shelf is WS and the weight of the book is WB. The bar is at an angle theta to the shelf and exerts a force on the shelf. The shelf is in equilibrium. So it's a case of equilibrium. Remember again, equilibrium questions can be solved in two possible ways. The one is called what are the magnitudes of the horizontal and vertical components? What are the horizontal and vertical components of the force of the wall on the shelf at P? Okay. So examiner wants to see the horizontal and vertical components of the force on the wall. So we should update the diagram. What is this force F? Hmm. I have resolved the force and the system is in equilibrium. So clockwise moment is equal to anti-clockwise moment. There is no competition for the horizontal component. There is only one horizontal component, which is F cos theta. So F cos theta has no competition. So it means on this, the magnitude of the horizontal vertical component of the force on the wall, force of the wall on the shelf. So that is obvious then. Horizontal component would be F cos theta. So C and D are not possible. No competition. So what about this one now? We should make an equation for vertical component, because F sine theta is upward, WS and WB are downward. So now I have shown the working. Select the right option then.
It's B.
The diagram shows a uniform beam PQ. The length of the beam is 3 meters. Uniform means it is evenly in mass. So the center of gravity will be at the center, 1.5. Weight is 50. So we can get the weight also. The beam is supported on a pivot 1 meter from NP. A load of weight W is hung from NP. The beam is in equilibrium. Now I've shown the working, and can you help me to write down the equation now, like W
So
W into 1
is equal to 50 into 0.5.
50 into 0.5.
It is coming as 25 Newton.
It's too simple actually. In A level, it's interesting if a question looks to be very so simple, then if people get confused that maybe this is wrong. A ball is rolling down a slope at a constant speed. Constant speed is something very important. The three forces acting on the ball are the weight, the contact normal force, and the friction. The ball is rolling down. Yes, the ball is rolling down. I'm showing the possible forces on the figure. Now, you know that it should be a head to tail version. It should be a head to tail version, but A is not a right option because A is showing resultant. So A is wrong. We do not need resultant here. B is an option. C cannot be. C shows resultant. So you have to select between B and D. The main diagram is shown above. Weight, R, and friction. What's the difference actually in between B and D? B and D are actually very close.
The arrows are also pointed towards the same direction.
The diagram is only in terms of angle.
D has a slightly larger angle and B has a smaller angle.
This is the only difference which is visible. This is, if I say θ1, and this is θ2. Now, can you suggest a solution? Because only one thing is there, that R and F. Here, friction is a bigger force compared to R. And in D, interestingly, F and R are looking nearly equal.
So will it be B?
This is the right answer.
Because of a larger angle.
No, the friction and R are nearly equal. The problem with B is there that in B, friction is looking to be a bigger force than reaction force, which is not possible. How come friction can exceed the reaction force? A couple couple is a pair of forces which always tends to produce rotation. A couple applies a clockwise torque of 9 Newton meter to a circular disc. Which diagram shows this couple? Couple is a pair of forces which tends to produce rotation only. And couple is able to produce a torque. What is the formula for torque? F into D, one force into separation.
Isn't it the same as the moment?
But in moment you take the distance from the pivot, right? But in torque, you do not consider in torque, you do not consider the pivot. So there are four options. We need to get an answer of 9. Interestingly, where we can get 9?
The first one shows 4.5.
Sorry, 4.5. Yes, 0.45.
4.5, the first one. The second one shows 1.8. And C again shows 4.5. But D is showing 90. D shows 90.
But option is not coming, no?
Okay. I think there's a mistake in the D. It should be 100 over 100.
I'm making a mistake. You
Then
pointed. Yes, you got it perfectly right. It is 9. So a rigid circular disk of radius r has its center at x. A number of forces of equal magnitude F acted in the edge of the disk. All the forces are in the plane of the disk. Which arrangement of forces provides a total moment of magnitude 2Fr? Total moment means sum of the two moments. So same, I think it looks to be a case of torque. I show the R here. So it will be, the first one would be F into 2R, the total moment. Here, Now, what do you suggest the required answer?
I think it's A.
That looks fine. So we have done some questions. I was willing to have at least a question on upthrust. Upthrust is a topic from this